Next, we're going to take a look at how to apply information about quadratic functions. In example 3, we are given an equation for revenue versus units sold for a health food company. What the health food company wants to know is how many units do they need to sell to maximize their revenue. Think about this parabola opening down. The reason it opens down is because it is not in standard form. We have to look at the leading coefficient, which is the coefficient of x squared. Our coefficient is negative, so this will open down, which means the vertex will be a maximum instead of a minimum. To find the vertex, we will first find the axis of symmetry, opposite of b over 2a. b is the coefficient of x, a is the coefficient of x squared. Dividing these, we get 4,500. This is our x value. It says x is the number of units sold. The question says determine number of units sold. Therefore, we don't have to go back and find the y-coordinate. In this case, the y-coordinate would represent the actual revenue or the maximum revenue this company would earn. Example 4, we are given an equation for gas mileage based on the speed. What speed for this particular car, because it's different for each make and model, would give us the best gas mileage. Again, this graph would open down, so our vertex is a maximum. So we want to find, in this case, it would be the p-coordinate of our vertex, opposite of b over 2a. Our b is 3. A is negative 1/28. When you are typing this into your calculator, be careful that you either put parentheses around that multiplication in the denominator, or you multiply those together first. If you do not use parentheses in the denominator, your calculator will take -3 and divide it by 2 and get that answer first before it multiplies by the negative 1/28. You do not want it to do that. So make sure you, again, either use parentheses around the 2 times negative 1/28 or multiply those two values together first. I got 42 for my speed, which is in miles per hour. This question had 2 parts. What is the car's best gas mileage, which we haven't answered yet, and at what speed is it attained? We found the speed first, so to find the gas mileage, we will put that speed back into the equation for P. I got 32 miles per gallon as the best possible fuel efficiency for this car when you drive 42 miles per hour. Our last example, we are not given an equation, so we have to write it. We have 140 feet of fencing. That would be the perimeter of our vegetable garden. We want to know how to maximize the area of our garden. The 140 feet we have to enclose our garden would need to be split up among 2 lengths and 2 widths for our garden. To get an equation for our perimeter, we would set that 140 feet equal to L plus L, or 2L, plus the 2 widths. The question was, how do we maximize the area? The area of our garden would be length times width. The problem with this formula is that we have 3 variables. We don't know what the area or the length or the width are. So what we will do is use this perimeter formula to solve for one of the variables so that we can substitute it into our area formula and have just 2 variables to work with. It does not matter which variable you solve for. I'm going to solve for the length, so I'll subtract 2w from both sides and then divide everything by 2. Notice I divided everything by 2. I'm going to sub this expression for the length into my area formula for length. So I'm replacing the length with the expression that I got when I solved the perimeter formula. Distributing my w to put this into standard form. We now have a quadratic equation that we can find the vertex for. It will also be the maximum point. As our graph would open down, we have a negative in front of our w squared. To find that vertex, opposite of b over 2a. b is the coefficient of w. A is the coefficient of w squared. Negative 70 divided by negative 2 gives me 35 feet for my width. Making sure that we answer the question we were asked, we are told to find the dimensions of the largest area she can fence. We have one value of the dimensions. We have the width, which is 35. We'll sub that back into the formula that we had for the length to solve for the other dimension. 70 minus 35 gives us 35 feet for the length as well. So the dimensions of the rectangle that she could fence with 140 feet to maximize the area that she could grow vegetables in would be, in this case, a square, 35 feet by 35 feet.